Hello everyone. Welcome back to Online Gate Training 2023 on Hydrology and Irrigation Engineering of Session 3. I'm Sushmita GS, working as an Assistant Professor in the Department of Civil Engineering, Vidyavardhaka College of Engineering, Mysore. In the previous sessions, we have seen problems on rainfall, that is precipitation data, and in the last session we have seen a problem on unit hydrograph, and also we have seen some of the theory concepts which you should remember, and the formulas which you should remember to solve the problems. In the today's session, so we'll continue with the problems which was appeared in the previous gate exams. So we have taken gate 2022 set 1 paper in the previous session, and we have solved this particular problem, and that is based on irrigation efficiency. I hope everyone are clear about this question. And so today we'll solve problems on unit hydrograph before solving the question which was actually appeared in the exam. So I just wanted to solve two more problems, so which is normal problem, so that it will be help for to solve the question which was appeared in the exam. So let us read out the question. So you can see the question on the screen. So it is like this: the hourly ordinates of a 2-hour unit hydrograph are given in the table. Okay, derive 6-hour unit hydrograph. Clear? For the same catchment. So they have given the time, and then they have given the discharge. So if you see here, they have given the time from 0, 1, 2, 3 with an interval of 1 hour, and then discharge, which is in Qmex, they have given so 1, 2.75 with respect to the time. Okay, so now what you have to do, and hope you know the definition of unit hydrograph. So what hydrograph means, it represents the the discharge versus time. So where for a 1 centimeter rainfall, or the 1 centimeter of runoff for a given rainfall. So here, if you want to convert 2 hour to 6 hour, what you should do, you should add all the 2 plus 2 plus 2, so you'll get 6 hour. Okay, just a moment. So what you should do, you should convert 2 hour to 6 hour. As I told, the given is so 2 hour, and so you should convert that into 6 hours. So for that, what you have to do, so if you want 6-hour unit hydrograph, so you have to multiply, or you have to add 2 plus, that is 2-hour unit hydrograph twice. Okay, then it will convert into 6 hour. So if you see here, so first, so let us tabulate the given data. So if you see the first column, so here the first column represents your time in hour, and the second column represents the unit hydrograph ordinates, which is given in Qmex. So you just write down all the given data. Then the third column, okay, that is ordinate of 2-hour unit hydrograph. So for a 2-hour lag, so as I told, see, every unit hydrograph or rainfall occurs after 2-hour lags, because it is a 2-hour unit hydrograph. So what you should do, first one is for a 2-hour lag, so you should start from 2 hour. Okay, so what you should do, you should write down the given, that is for 0 you will get nothing, and for 1 hour also you should get you won't get anything. Whatever here 0 is there, you can see the arrow mark. So this 0, so whatever the 2-hour unit hydrograph ordinates are there, so you should start writing the same values for a 2-hour lag. Means you should start for a 2 hour, you should start from a interval of 2 hour. So 0, the same values which we have written here, you can see here. Okay, so 0, next 1, 2.7, and again like that 5, and then 8, 9.8, 9. So like this, you write down all the given 2-hour unit hydrograph for a 2-hour lag. Similarly, write all these for a 4-hour lag means, so again 2-hour lag, so it will be 4-hour lag. So for a, you should start from time interval of 4 hours. So again 0, 1, 2.7, the same values you should start writing. Okay, then the fifth column you can see the total combined unit hydrograph. So you're adding all the 2 hour unit hydrograph. So you can see you add all the 3 columns, that is column number 5, that is 5 is equal to 2 plus 3 plus 4. You should add all these 3 columns, so you'll get the total combined unit hydrograph, that is the fifth column. Okay, and the sixth column is you're converting that unit hydrograph to ordinates. Okay, you're converting, so this total combined unit hydrograph to a 6-hour unit hydrograph. So the 6-hour unit hydrograph, so will be what you have to do. So that is again in terms of QMX means, so whatever this total combined, that is fifth column is there, so you should divide this fifth column divided by 3. Okay, as I told, you're adding 3 unit hydrograph, right? So 3 unit hydrograph means, so your 1 unit hydrograph represent 1 centimeter of runoff or 1 centimeter of rainfall. So 3 means 1 plus 1 plus 1. So it is total runoff is 3 centimeter. So sixth column, how you will get? Ordinate of 6-hour unit hydrograph, that is fifth divided by 3. Clear? So that is ordinate of 6-hour unit hydrograph is equal to combined total, that is total unit hydrograph divided by 3. So 3 represents 3 centimeter of runoff. So that is your sixth column. So you can cross verify how you can check. So you can see here, you can sum the column number 2 and column number 6. So both the values should be equal. Clear? So that is your the first problem, that is conversion of a shorter duration of unit hydrograph to longer duration. So you just cumulatively adding the unit hydrograph. So that is your conversion of 6-hour unit hydrograph to 2-hour to 6-hour. So coming to the second problem, so which I know wanted you to know, so that is based on the S curve method. So the question is like this. I'll just given below are the ordinates of 4-hour unit hydrograph, okay, of a basin in meter cube per second at 1 hour intervals. Okay, so again it is, they have not given in a table form, so they have given a 4-hour unit hydrograph. Okay, so with an interval of 1 hour. Okay, so these are the values, that is 4, 25, 44, 60, 70. So that is all the the ordinates of unit hydrograph which is given in QMX. And then what you have to do, you have to construct the S curve hydrograph using 4-hour unit hydrograph, hence derive 2-hour unit hydrograph. So if you compare, and also they have given the area of basin 195.84 kilometers square. So if you compare this particular problem with the previous problem, see in the earlier one, so they have they were there was 2-hour, the given hydrograph was 2-hour, and you have to convert that into 6-hour. Okay, that was the earlier case, but here they have given 4-hour. You should convert that into 2-hour, means longer duration, you should reduce it to shorter duration. So in that particular case, we are going to use the S curve method. So when you convert longer duration to shorter duration, so you should use the S curve method. So here the given data is like this. So the given is the capital T naught, that is nothing but the duration 4-hour, and so you should the required is 2 hour. You should calculate what is the 2-hour unit hydrograph. Meantime, you should also construct a S curve. Okay, so and the area of the basin is given as 195.84 kilometers square. And so let us, this is also you should solve it in a tabular form. So first you make a list of the given unit hydrograph with respect to the time interval. So the tabular column looks like this. You can see the first column represents your time, okay, t within 1 hour interval. They have mentioned within 1 hour interval. So you should start from 0, 0, 1, 2, 3, 4, 5, 6, like this. And the second column, if you see, so that is the given ordinate of 4 hour unit hydrograph, which is given. Okay, 0, 4. If you see here, the previous whatever that is given, 425. So you should just note, make a list of all those data. So 4, 25, 44. So till 20 hour you will get it. So how to convert this 4 hour to 2 hour and how to construct S curve. So the first thing is the third column. If you see the third column, S curve additions. Okay. So within lag of minus t minus 4 means, so in the next unit hydrograph, so the given is how much, 4 hour. So that's why the next unit hydrograph will be, that is the next rainfall occurs after 4 hours. Okay, so it is a 4 hour lag. So if it is 2 hour unit graph, then the lag will be 2 hours. So here it is 4 hours, so the lag will be 4 hours. So you should start from 4 hours. Okay, you can see here where we have started from 4 hours. So now here, so how you should do, so here it is like the first column, whatever 0 is there, 0 plus this, so you will get 0, and 4 plus this you will get 4. You can see here, or you can just write down that in the S coordinate. Okay, so then you can write, parallelly you can see the arrow mark how it is calculated like this. And 25 is, there is nothing, it is just 25. And 44 also you will get as it is 44. And 60 plus 0, it is 60, so it is here 60. And 70 plus 4, it is 74, which you should write it after the, subsequently you should write like that. And then 61 plus 25, so it is 86. You can see here 86, that 86 comes here. And again 52 plus 44 is 96, and that 96 you should write down here. And similarly 45 plus 60, it is 105, and this 105 is carried here. And 38 plus 74 is 112, which is again carried here. So similarly you should construct this S curve additions, so till the last, the row. And then, so parallelly you will get column 3 and column 4. So column 4 represents S curve ordinate, so that is for time t. Again it is in meter cube per second. So as I told, it is column 2 plus column 3. Okay, so what is this column 5? Column 5 is S curve lagged by 2 hours. So what you should do, so if you see this particular question, the question is, so 4 hour you should convert into 2 hours. Okay, so that's why the fifth column represents S curve lagged by 2 hours, means t minus 2. You are converting 4 hour to 2 hours. That's why, so whatever you should consider the required unit hydrograph. So it is 2 hours. So the lag will be 2 hours. So you should start from the time interval 2. You can see the 0 which we have started from 2 hours. Okay, so what you should do, so this 4 will be carried to here, and 25 here, like this, 44, 60. You can see here how the 6 S curve lagged by 2 hour has been calculated. So 96, you just write down the column 4 values in column 5 after 2 hour. That's it. Okay, so this is 112, 118, 124. So that is your S curve lagged by 2 hour. So calculate the difference. The column number 6 represents your delta y, because so this is actually 2 hours. So to calculate ordinate of 2 hour unit hydrograph, so it is S1 minus S2, that is nothing but delta y, the difference between two S curves into T naught divided by T naught, that is capital T naught divided by small t naught. So small t naught is required and capital T naught is the asked one. Okay, so first calculate delta y, that is the difference of two S curves. So 0 minus so nothing, you'll get 0. And the second one is 4, and 25 minus 0, you'll get 25. 44 minus 4, again you will get 40. 60 minus 25, you will get 35. And again 74 minus 44, you will get 30. Similarly, okay, so column number 4 minus column number 5, so you will get column number 6. Okay, then you convert whatever the 4-hour unit hydrograph is there to a 2-hour unit hydrograph, that is column number 7. The ordinate of 2-hour unit hydrograph is, so this delta y, the column number 6, into, so the required given is what, 4, divided by required is 2, that is capital T naught by small t naught is 4 divided by 2. So you will get the ordinate of 2-hour unit hydrograph. So that is your column number 7. So, and then how you can check whether the given, whether the calculations are correct. So you add all the 4-hour unit hydrograph which is given, and the 2-hour unit hydrograph which you have calculated, so you should get the same total. So that represents your calculations are right. So this is first one which we have discussed is converting the longer duration to, sorry, shorter duration to longer duration. So it is just normally adding the unit hydrograph. So when it is given longer duration and you have to convert that into shorter duration, then you have to go for S curve method. So you should remember this when you have to use just addition of the unit hydrograph, or when you have to use the S curve method. So that is about this particular problem. So now we'll come back to the question which was asked, the second question which was appeared in GATE 2022 in set 1 question paper. The question is like this. You can see here the 2-hour duration storm event with a uniform excess rainfall of 3 centimeter occurred on a watershed. Okay, so the ordinates of stream flow hydrograph resulting from this event are given in table. So you can see here, so they have given again the time and the stream flow, so in meter cube per second, and the given duration is how much? It's a 2-hour. Remember, it's a shorter duration, 2-hour is given. Okay, considering the constant base flow of 10 meter cube per second, the peak flow ordinate, that is in meter cube per second, of 1-hour unit hydrograph. So if you see here, so they have given 2-hour. So you should calculate what is the peak flow for 1-hour unit hydrograph. First, what you should do, you should convert 2-hour to 1-hour. So you can see here it is longer duration to shorter duration. So which method you should use? You should use S curve method. And also if you see here the stream flow hydrograph, so they have given the stream flow hydrograph, means the storm hydrograph, whatever this 10, 16, 34, 40, 31 is given. So it is the storm hydrograph, and they have given the base flow of 10 meter cube per second. So the first thing is you should convert this storm hydrograph to unit hydrograph. Okay, first you should so convert the storm hydrograph into ordinate of unit hydrograph. So for that, so first what you should do, you should calculate what is the direct runoff hydrograph, that is DRH, you should calculate. Okay, so that is the first thing. So how we'll do, so how you will get this direct runoff hydrograph from the storm hydrograph, whatever the given data is there. So if you subtract the base flow should be minus. Okay, so if you subtract the base flow, it will be converted into direct runoff hydrograph. Then you convert that direct runoff hydrograph into unit hydrograph. So as they have given the, so rainfall excess, that is 3 centimeter. So direct runoff hydrograph divided by rainfall excess, okay, RE, which is 3 centimeter. So you will get the unit hydrograph. Okay, so this represents your unit hydrograph. Direct runoff hydrograph divided by RE, you will get a unit hydrograph. So what is this direct runoff hydrograph? So direct runoff hydrograph is, So the given a stream flow, okay, I'll just write it in a short form, stream flow, okay, or we can also call it as storm hydrograph minus base flow, okay. So this is your, the conversion. So next, after that, once you get the unit hydrograph, so the procedure which we followed in the previous problem, that is S-curve method, so the same you can use. So the solution you can see here. So the given is 2 hour storm duration and rainfall excess is 3 centimeter. Base flow is 10 meter cube per second. The ordinates which is given. So make a tabular column. So the first one is the time interval. So which they have given 0 to 7 with an interval of 1 hour. Then ordinate of 2 hour direct runoff hydrograph. I told you the first you have to calculate direct runoff hydrograph. So which is whatever the stream flow minus base flow. So 10 minus 10. So you will get 0. Next 16 minus 10. So it is 6. So similarly the other values. So you should subtract all these values. So with the base flow, then you will get ordinate of 2 hour direct runoff hydrograph. So that is your column number 2. And column number 3 is you're converting this direct runoff hydrograph to unit hydrograph. That is ordinate of 2 hour unit hydrograph is equal to what? Ordinate of 2 hour direct runoff hydrograph divided by rainfall excess of 3 centimeters means. So you should divide all these, TRH by 3 centimeters. So 0 by 3, 0, 6 by 3, 2, 24 by 3, 8. Okay, so that is your ordinate of 2 hour unit hydrograph. So after that, you calculate the S1, S2, that is S curve lagged by 2 hours. So you can see here. So what is the duration? It is a 2 hour duration. So the time lag will be 2 hours. So you should write down these values with the 2 hour lag. You can see here we have started with the 2 hour interval. So 0 plus nothing, it is 0 here, and 2 plus, so nothing, it is 2, and 8 plus 0, it is 8 again, and 10 plus 2, it is 12, and 7 plus 8, it is 15. So you can see here how the column, fourth column we have got, and 5 plus 12, it is 17 again 15 plus 2, again you will get 17. So you will get the same values, after some interval. That is your S1. And then S curve ordinates. Okay, so that is nothing but, so you should write down the same values, that is 0, 2. So you can see here 0, 2, and then 8, and then 12, 15, 17, 17. So it is similar to the calculation of S curve. Okay, and then what you have to do, so now you got the S1 and S2, you should convert 2 hour to 1 hour. So 1 hour unit hydrograph means it is a 1 hour lag. So you should start writing down these values with a 1 hour lag. So you can see here we have started with 1 hour lag. So 0, and then 2, 8, 12, 15, 17, 17. Okay, so this is your S1 with 1 hour lag. So later calculate the ordinate of 1 hour unit hydrograph. So that is delta y. Delta y is S2 minus S1. Okay, divided by or multiply by T naught, that is capital T naught divided by small t naught. So, okay, so capital T naught is how much? It is 2. Okay, and small t naught is 1. So it is, so 2 by 1, so it is multiplied by 2, or you can see it is divided by, so t naught. So anything is fine. So then you will get the ordinate of 1 hour unit hydrograph. So 0 minus 0 divided by multiply by 2, you will get 0, and 2 minus 0, it is 2, into 2 you will get 4 here, and 8 minus 2, it is 6. 6 into 2, it is 12. So that is your ordinate of 1 hour unit hydrograph. So what is the question? If you see the question, so what they have asked the peak flow ordinate. Okay, peak flow. So if you see the last column, what is the peak flow here? What is the maximum flow? You can see 12. So 12 is the peak flow. The answer is 12 meter cube per second is the answer for this particular solution problem. I hope everyone are clear with this. First one is unit hydrograph, purely unit hydrograph, and the second one is S curve. The question which was appeared is also on S curve. So let us move to the next question. So that is from the GATE 2022 set 2. Okay. So the first question is like this. In a certain month, the reference crop evapotranspiration at a location is 6 per day. Okay, so they have given evapotranspiration. If the crop coefficient and the soil coefficients are 1.2 and 0.8 respectively, what is the actual evapotranspiration in per day? So the options given are A 5.76, B 7.2, and C 6.8, and D 8. So this was a one more question. So I hope you know the theory regarding that evapotranspiration. It is a combination of transpiration plus evaporation, and they have given the coefficients, crop coefficients and soil coefficient. It is just actual evapotranspiration means, so it is the crop evapotranspiration multiplied by crop coefficient and soil coefficient. So that is just a simple question. It is, the theory is you should know what is evapotranspiration. So as I told, sum of transpiration plus evaporation is evapotranspiration, and as I told, so you can see actual evapotranspiration is crop evapotranspiration into, so you can see E naught is equal to E1 into C1 into C2. Okay, so E naught is nothing but modified or actual evapotranspiration, and E1 is the original evapotranspiration, and C1 is crop coefficient, and C2 is soil coefficient. So if you see what is given, so they have given both crop coefficient and soil coefficient, and they have given the reference crop evapotranspiration. So you just need to multiply. So the solution you can see here. So they have given ET naught, that is 6 per day. Okay, and or the formula you can see the same, C1 C2 or Kc Ks, it's just a constant. So the actual based on the Buzzell's equation, so the reference evapotranspiration or the actual evapotranspiration is, so it is 1.2 into 0.8 into 6. It just multiply the coefficient with the given evapotranspiration, you will get the actual evapotranspiration. So it is 5.76 per day. So you don't need to convert, so you keep it in the same. So the answer is 5.76 per day. So this is a problem on evapotranspiration. So the next question is like this. So a flood control structure having an expected life of n years is designed by considering a flood of return period t years. When t is equal to n and n tends to infinity, the structure's hydrologic risk of failure in percentage is. Okay, so you have a flood control structure and the return period is t years. Okay, and so the lifespan is expected to be n years, and when t means your return period is equal to the lifespan and also the n tends to infinity, then what is the the risk of failure, the probability of failure you should calculate. Okay, that is probability of occurrence and probability of failure. So for that, the concept behind which you should remember is what is return period. So the return period is the time period on an average, after which peak flood discharge is likely to be equal or exceeded. So it is also called as recurrence interval. Okay, after the peak flow, peak flow, how much may be the the flood. So we are going to, usually what we are going to do, we are going to design the structure for 25 years, 50 years. So that is the return period which we are going to consider as an peak flood time period. That is your return period, which is capital T. So the time period on an average after which peak flood discharge is likely to be equal or exceeded. And then reliability and risk. So these are the things which you should know to solve this. Here it is the probability that the particular value of peak flood discharge is never equal or exceed in the design life of the structure. So that is your reliability. The risk. So risk is equal to 1 minus reliability. So risk is the probability of occurrence of flood. Okay, so at least once in the design period. So that is your risk, means it is a probability of occurrence. And reliability is probability that particular value of peak flood discharge is never equal or it won't exceed. So that is the things which you should remember. Risk is equal to 1 minus reliability. And the formulas which you should remember is probability of occurrence, so which is denoted by P is equal to 1 by return period or time period. And so Q is equal to 1 minus P. So where again based on the binomial probability distribution, so we have different normal distribution, all those things. So the probability of flood exceeding the design value r times in n years is given by, so probability of r comma n is equal to ncr into p to the power r q to the power n minus r. So these are the formulas which you should remember to solve this particular problem. So let us go to the problem now. So if you see here, they have given t return period t and lifespan is n years. Okay, and what is the percentage of failure which you should calculate? So if you see the solution, the given data, see the return period t which is given, and it is also given t is equal to, when t is equal to n and n tends to infinity, what is the percentage of risk? So you should basically calculate risk. So risk is equal to 1 minus q to the power n, which you should remember the formula. Risk is equal to 1 minus q to the power n, so which is equal to 1 minus, so q is what, 1 minus p again, so which you know already, and p is what, it is 1 by t. So the risk is equal to 1 minus of 1 minus 1 divided by t whole to the power n. And what is the condition? For t is equal to 1 n and n tends to infinity, so what will be the risk? So risk is equal to 1 minus 1 divided by e. So whatever this value is there, so this will become 1 divided by e when n tends to infinity. Okay, so if you do the calculation in the calculator, so you approximately will get 0.632, so which is 63.2 percentage, so is the answer. So the answer is 62.3 for this particular problem. So you should remember these formulas. What is the formula for, the probability of occurrence, and then what is P, Q, risk, all these things you should remember. So the next question is match the following. So here, they have given two columns. So with the equations, so it is based on the equations. So which of the following combinations are correct? So you can see column numbers X, that is Horton equation, Penman, Chassis, Lacey's, Dickens. So and column Y represents design of a level channel. So basically, which formula is used to calculate which parameter? So as you know, Penman, Horton's, so we usually call it as Horton's infiltration equation. So Horton's is used to calculate infiltration and Penman is used to calculate evaporation. So you just check. So P is 4. So you can see P is 4 is there in option A and option C also. Then you see Q. Q is for Penman method is for evaporation. So you can see here, so Q is there for 3 in both option A and option B. So we'll go to the Chassis formula. So why Chassis formula is used? Chassis formula is used to calculate maximum flood discharge. Okay, so then you can see here, so option number C as R is equal to second, that is maximum flood discharge. So option C is correct. So if you see here, R, that is Chess's formula, is not used to calculate the flow velocity. So the answer is option C. So that is your match the following. So the question number 3, which was appeared in set 2. So now this was all the gate 2022. So we'll move to the gate 2021 set 1 and set 2. So in the gate 2021 set 1, so the first question was this: an unlined canal under regime conditions along with a sill factor of 1, okay, sill factor is 1, has a width of flow is 71.25 meter, assuming the unlined canal as a wide channel, the corresponding average depth of flow, okay, in meter, round it off to 2 decimals, you should keep it in 2 decimals, in the canal will be. So basically what you should calculate, you should calculate what is the average depth of flow. So in different textbooks you can find different terminologies, either you can use it, some authors will use it as D, some authors will use it as Y. Okay, so you can use whichever you prefer. So average depth of flow you should calculate. For that, sill factor is given, and then they have given the width B is given, and also I think that's it. So they have mentioned it's an unlined canal under regime condition, and also it's a wide channel. So when it is mentioned wide channel, your hydraulic radius will be directly equal to your width of the channel B. So that condition you should remember. And the theory, you should know how how to design the canal procedure. So we have different methods, Kennedy's method, Lacey's method to design the canal. So basically the concept which you should remember and the formulas which you should remember is, so design of canals by Lacey's method. So you can see the sill factor, if it is not given, so here the sill factor is directly given. Okay, sill factor F is equal to 1.76 root D, mean. And then so D mean is nothing but the average sill particle size in mm. It varies from 0.05 for very fine silt to 0.32 for standard silt. Okay, and then you should calculate the velocities. So and then area, so it is the area, it is, if you know the discharge, then you can use the continuity equation, Q is equal to A by A into V. So from that you will get area, and then perimeter is 4.75 root q, and then so perimeter b plus 2d root 1 plus n square, where n is nothing but your side slope. So if you assume side slope as 0.5 horizontal to 1 vertical, then you will get area as bd plus d square by 2, and perimeter as b plus root 5 into d, and then hydraulic mean radius r divided by R is equal to A by P. So these are the formulas, and the formula for you know uh, just a moment. So which you should remember also is for the velocity. So which I'll tell you in the next slides. So for the velocity and for the slope. So that also you should remember. So now here let us solve this particular problem. Coming to the solution, so here is the solution. So you can see here, I know what is given. So they have given the sill factor F as 1 and width 71.25 meter. As per Lacey's theory, the hydraulic mean radius R is equal to 5 divided by 2 V square divided by F. So this is a formula for hydraulic mean radius. And similarly, the mean velocity V is equal to QF square by 140 whole to the power 1 by 6. So these formulas you should remember. And also, as they have mentioned in the question, it is a wide channel. So your R is directly equal to your depth of flow, which is Y. Okay, and so if you take this condition, then so if you substitute R as Y, then your So this hydraulic mean radius, so you just substitute r is equal to y here in this particular formula, then average depth of flow y is equal to 5 divided by 2 into v square by f. Okay, so now first you calculate, f is given, so you calculate what is v, then you will get average depth y. So to calculate v, you should have discharge. Okay, so how to calculate discharge? So now let us see how to calculate discharge. So you have the perimeter equation. Okay, 4.25 root q. Okay, and perimeter is equal to what? Width, since they have mentioned it's a wide channel. Okay, and it's a unlined channel, so your perimeter is directly equal to your width, which where the width is given. So width is how much? 71.25. So you substitute that, so you calculate q. So from this you will get q. So q is 225 meter cube per second, and you substitute this q here in the velocity formula, you will get the velocity. So q is 225, f is 1 divided by 140 whole to the power 1 by 6, so you will get v, and then you substitute that v here, average depth of flow, that is 5 by 2 v square divided by f, so you will get the average depth of flow in meters, that is 2.938 meter. Okay, so that is the answer. So you should round it off 2 decimals. The answer is 2.938 meter. So this is the solution. Basically you should remember the formula, so for the according to the Lacey's theory. So coming back to the second question, which was appeared in 21 set 1, two reservoirs are connected through, I'll just read out the question here. So two reservoirs connected through a homogeneous and isotropic aquifer having hydraulic conductivity K, which is represented, hydraulic conductivity is represented by K of 25 meter per day, and effective porosity n of which is n of 0.3 as shown in the figure, not to scale, and groundwater is flowing in the aquifer at the steady state condition. And if water in reservoir 1 is contaminated, then the time in days, round it off to 1 decimal, taken by the contaminated water to reach the reservoir 2. So basically you have two reservoirs as you see here in the figure. So how much time it will, the water will take to flow from reservoir 1 to reservoir 2. Okay, so that is the um, question. And here you can see aquiclude is there and aquifuge is there. So it's an unconfined aquifer and it's a steady state condition, you should know. So basically hydraulic conductivity, the formula is hydraulic conductivity, so and transmissibility, there is a relation between hydraulic conductivity and transmissibility. So using transmissibility formula you can calculate hydraulic conductivity. For that, first you should calculate transmissibility. So to calculate transmissibility you should remember, so what is the formula for unconfined aquifer for a steady state flow? So if you see, for this, you should also remember the Darcy's law. So which you already know, the flow of rainwater through a soil is governed by Darcy's law. So that is, it is valid when the flow through the soil is laminar. Okay, as per this law, for a lamina of through homogeneous soil, the velocity of flow is given by what? V is equal to K into I, where K is what? It is the coefficient of permeability, or it is also called as hydraulic conductivity. And what is I? I is the hydraulic gradient, which is given by H divided by L. And V is the discharge velocity or superficial velocity, and H is what? It is the differential head. So if you see the question, so they have given the two heads for two reservoirs, 30 and 10. So the difference between these two will give you the small h. So that is the theory behind this. As I told, you should remember what is coefficient of permeability and what is seepage velocity, and formulas for seepage velocity and discharge. So if you see the solution, as I told, K is given, that is the hydraulic, 25 meter per day hydraulic conductivity, and N porosity is given 0.3, and L, which is 2 kilometer which is converted into 2000 meter. And head difference, as I told, they have, if you see the question here, they have given the H1 and H2. So basically, I know you should calculate here the how much time it takes. Okay, sorry to disturb, because earlier I told you should calculate hydraulic conductivity, but that is a different question. So here you should calculate how much time it will take. Okay, for that the given are hydraulic conductivity 25 meter per day and N zero point 0.3 and L 2000 meter, and as I told, head difference is 30 minus 10, 20 meter. Hydraulic gradient, that is H by L, so which is 20 divided by 2000. And then velocity K into I, so you'll get the velocity, basically velocity, distance divided by time taken, using that. And actual velocity is, so discharge velocity divided by porosity. Okay, so discharge velocity is 0.25 meter per day divided by porosity, you will get 0.833 meter per day is the actual velocity. And the number of days required by the contaminated water to reach the reservoir 2 is, again we are using the general concept, velocity is equal to distance divided by time. So velocity, how much we got, 0.833 is equal to distance is, it is 2000 meter divided by time. So the time only you should calculate, so you will get 2400 days. So this is the solution for this particular problem. We have used the normal Darcy's law, and then general velocity definition. So this is all for today's session. Thank you all, and if you have any doubts or clarification, so you can contact through the mail, or you know you can just mail whatever the doubts, so we'll just try to clarify that. Thank you.